Okay, in this lesson we're going to be talking about how to add or subtract polynomials. And poly just means multiple parts of the numbers. Nomial talks about numbers. So in polynomials you're going to have numbers and letters that have exponents, and these letters are called variables. So the main thing to keep in mind when you're adding polynomials is that you can only combine like terms. What that means is that when you're combining something, you're actually adding or subtracting. If you're subtracting polynomials, the coefficients, as long as the variables that are next to the coefficients have the exact same exponent. For example, this 9 is next to an x cubed. This 4 is also next to an x cubed. So since the x's match and the exponents of the x's match, you can say that you have 9 x cubes added to 4 more x cubes. They're the same thing. So you can combine them to be 13 total x cubes. However, if you have something that does not match as far as the exponent, even though you have x's here and x's here, this is an x square and this is an x cubed, so you can't combine those. Whenever you're adding polynomials, remember you can combine them horizontally or vertically. So in this case, they're lined up nicely. The x cubes are next to each other, are in the same position. The x squares are in the same position. The x terms, and then the constant terms. So you can match up the like terms. So when you're looking at combining, these x cubes can go together. The x squares can go together, or be combined rather. As you're looking at the coefficients here, the x's can be combined, and then the constants can be combined. So if you could just look at them and do the addition or subtraction, then that's fine. So the negative 11 and the positive 16 will go together to get 5, and you have x cubes. That's how many x cubes you had. The positive 7 and the negative 3 gives you a positive 4 x squares. The negative 11 and the positive 3 gives you negative 8 x's, because that's what they are. That's the term. And negative 5 and negative 15 added together make negative 20. Now you can also do it vertically. If you line it up vertically, it makes it a little bit easier to see which terms you can combine. You get the same answer. You still get 5x cubes, 4x squares, negative 8x's, and negative 20. But sometimes lining it up vertically helps, especially if there's a missing term in there. All right, so let's talk about subtracting polynomials. Again, you're going to only combine the like terms, kind of like what we did with adding, but you're going to distribute the minus sign by changing all the signs of the coefficients afterward. For example, this polynomial minus this second polynomial, this negative has to be distributed to each term that it's affecting, okay? Since this minus doesn't affect what we started with, all of those terms just get copied down exactly the way they are. It's really helpful to go ahead and distribute it and rewrite it. This positive becomes a negative, the negative becomes a positive, the negative becomes a positive, and the positive becomes a negative. And it's helpful to write it out instead of doing it in your head, so that what your eyes see match what your brain is trying to do. Now I've color-coded this, so my purple terms are my x cubes. I've combined those coefficients. My reds are my x squares. My greens are my x's, and my blues are my constants. So let's take a look and do one similar. So I would just rewrite the 10x cubed, the 5x squared, the 7x, and the 2, and then distribute this so that each of these terms is the opposite sign that it was originally, so that I don't have to worry about what my eyes are looking at and the math that I'm trying to do in my head. So now my x terms can combine to be 7x cubed. My x squared terms, negative 5 and positive 8, give you positive 3x squares. My positive 7 and my positive 5 give me positive 12x's, and my negative 2 and negative 6 give me negative 8. And that would be my answer. Now let's talk about product rules for exponents. Okay, so remember, an exponent is simply a shortcut that tells you how many times that base, this is called the base, is multiplied by itself. Okay,
So 2 to the 4th just means I've multiplied 2 4 times in a row. X to the 6th, again, means that I've multiplied 6 x's in a row. It's just a shortcut method, so we don't have to write all those out. So basically, any base, like 2 to the 4th times 2 cubed, is the same as 4 2's multiplied and 3 more 2's multiplied. So altogether, there are 7 2's. Similarly, if you multiplied x squared times x cubed, it's 2 x's multiplied, 3 more x's multiplied, you have 5 x's altogether. So basically the rule is that when you're multiplying the base, and again the base could be this 2 or the x or whatever you have, you just add the exponents because that's how many total you're going to have. So for this example, you have a y, and then you multiply it by 7 more y's. So it's the same thing as saying y to the 1 plus 7 because there's all of those being added, so you would have y to the 8. Again, you have 3 y's, 2 more y's, and 4 y's. So altogether, that would be 9 y's multiplied together. All right, now if you're multiplying them, you add the exponents, but whenever you raise something to a power, that means that you have that many of them. For example, we have 4 3 squares. So we have a 3 squared, a 3 squared, a 3 squared, a 3 squared, okay? So we know that whenever you multiply all the bases, then you can add the exponents. You end up with 3 to the 8th. Well, if you look, 2 times 4 is 8. So when you're raising to a power, you're actually going to multiply the exponents. When you multiply the bases, you add the exponents. But when you raise it to a power, you're going to multiply the exponents. All right, so then you get this rule that says that when you take a base that's raised to an exponent and you raise it to an additional exponent, you multiply them together. So in this case, x to the 4th 7 times in a row means that you're going to end up having 4 times 7, or x to the 28th power. Similarly, negative 5 to the 7th power raised to the cubed is the same thing as negative 5 to the 7 times 3, which is the same thing as negative 5 to the 21st power. That's how you would rewrite it with exponents. Now, let's talk about if you have multiple things being raised to an exponent. Each part of what's inside of the parentheses is being raised to the exponent, okay? So you can look at it this way, 2x times 2x times 2x times 2x, which means 2 was raised to the 4th power because there's 4 2's, and x was raised to the 4th power because there's 4 x's being multiplied. So each part would be raised to the power. And so 2 to the 4th is 16, and x to the 4th is x to the 4th. So basically you get this rule that says that if you have multiple things being raised to the power, each part is also being raised to the same exponent. So similarly, 5 cubed is 5 times 5 times 5, which is 125. And then x cubed is also being raised to the cube power, and so that would be your answer. Okay? So again, you're doing the same thing here. Negative 2 is being raised, and negative inside the parentheses means it's part of the being raised to the 5th power. Y was being raised to the 4th and to the 5th, so we already know we're going to multiply those, and so we would end up getting this. So let's try this. You can stop the video and try it, and then check your answer. Okay. All right, let's talk about multiplying polynomials real quickly, just to wrap up this last part of section 5.2. If you're multiplying the monomials, monomial just means that you have one part of the term, which is what we've been working with. If it has the same base, just multiply the coefficients and use the product rules, okay? So again, if you're multiplying a 2x times a 4x squared, you're just multiplying the 2 times 4 part to get 8. And the x times the x squared is going to follow the same rule we've just been talking about. So an x times 2 more x's means that you have 3 x's being multiplied all together. Again, here's another example where you're multiplying the coefficients. You multiply the variables by adding the exponents, and that is your answer. So try these, and the answers are on the left-hand side of the page, so you can check your work. If you want to multiply a monomial times a polynomial, that means you have one term being multiplied by multiple terms that, again, these terms are separated by an addition or subtraction. So when you do that, you need to actually distribute it. So this 3x squared times the 2x cubed, that part gets taken care of, and the 3x squared times the 5x also gets taken care of. So we take our coefficients and we work with those. We take our variables and we work with those separately. We took our coefficients and we worked with those. We took our variables and worked with those separately. Then when we're done, we go ahead and combine, like 3 times 2 is 6, and x to the 5th. 3 times 5 is 15, x cubed. Now, since the x to the 5th has a different exponent than an x cubed, I can't combine these anymore. That's as far as I can go. So we'll do this one, and we'll distribute. So the 3 times the 4 will give you 12, and the x squared times the x cubed means that there's 5 x's all being multiplied side by side. 3 times negative 5 is negative 15. The x squared times another x means I've got 3 x's being multiplied. The 3 times the positive 2 is a positive 6, and the x squared times, there's no other variables, so we just keep the x squared. Since this is an x to the 5th, an x cubed, and an x squared, we can't combine these anymore. All right, so let's just kind of make a note here that this 5x to the 4th and 6x to the 4th, when you're adding them together, become 11. You add the coefficients. But when you multiply them together, you multiply the coefficients and you multiply the variables. So the variables would change. Whereas here, you have 5 of these and 6 of the same thing. So you have 11 of those things. Whereas when I multiply, we're going to actually change the exponent. Keep in mind that unlike terms can be multiplied or divided. So it's okay if these are unlike versus when you're adding and subtracting them, they can't be. They have to be the same. All right, so stay tuned for the next video on multiplying polynomials using FOIL and the box method.